Hello everyone. Uh, my name is Mohammed Faisal, and I'm a student of Masters in Data Science program in University of Nicosia. In this video, I'll present my semester project for Big Data Management Processing and Data Management and Processing Systems, assigned by Dr. Dimitrios Trinas. The objective of this project is to design and implement an end-to-end big data analytics pipeline using stock market time series data as a realistic application domain. So the focus of project is not financial prediction or trading, but rather big data ingestion, persistent storage, distributed processing, and reproducibility. The project demonstrates how big data technologies such as MongoDB Atlas and Apache Spark can be combined to manage growing datasets that exhibit both volume and velocity. First, I would like to show you the project proposal approved before the start of the project and a walkthrough of the GitHub repository, which includes a README file, a brief about project scope, and all Jupyter notebooks that I have utilized. But first thing first, this is my project submission, which would look like that, and as instructed by Dr. Trenas, uh, I have included, or I'll actually be I have included this GitHub repository link to the GitHub repository here. And once this video is done, I'll upload it on the YouTube. I'll keep a link here, and I'll also keep a link for Google as a backup that where I'll include it in Google Docs because sometimes YouTube may remove any video. And as advised by the professor, so I have also included some deviations here, not a lot. Most of the and most of the times I have succeeded in implementing the project proposal. And so this was my project proposal, which so I wanted to design a system through which I can implement stock market analysis using the tools and techniques that we have learned in big data storage and processing system course of our master's degree program. So without further ado, if you allow me, I'll go to this GitHub repository, which is exactly the same link which I've already opened here. And this includes a README file. This file is having all the information about the project. Uh, also, it has the notebooks. So the notebooks which I have used for Jupyter for running the codes for step 3, 6, and 7, and I'll explain the steps later. Also, it has docs. So this folder is having the data model, the project proposal, and project scope. Uh, and I'll also show you the MongoDB cluster that I have implemented for the data ingestion for this project. So, and for project overview, this project is developed as a semester project, as I have explained earlier. So I won't be repeating it again. I'm running a bit short on time. So big data challenges which are addressed through this project are volume and velocity. And data sets and assumptions that we have taken is basically we have assumed the data set of eight US equity companies noted here. And we have taken almost 3 years of data set from two sources. One is Alpha Vintage API, and then second one is Stook. And this is basically the system architecture. So the project follows a modular big data structure, which is in which data ingestion, batch ingestion of historically daily OHLCV, basically as financial jargon, is taken, and then MongoDB Atlas is used for persistent storage, and then Apache Spark. PySpark is basically used for distributed processing, and then visualization is done through Jupyter notebooks. Uh, this MongoDB model is presented here, and this can also be further seen through the repository. The steps for data ingestions are provided as a step 3. So basically, why I've gone to step 3 directly is that in this README file, I have provided all the steps which I have undertaken to complete this project. So step 1 is project scope and big data framing. Step 2 is data modeling and persistent storage design, which is available in the repository. Then step 3 is data ingestion, which is which is basically done through Jupyter, through the coding system structured in Jupyter notebooks, as it can be seen here. And step 4 is data validation, which is again refers to the same file of step 3, and then feature engineering, and then distributed processing with Apache Spark, which is step 6. And this is the notebook for step 6, where all the codes have been provided. And then eventually step 7 is the visualizations, which is the core step of this whole entire exercise, where I have developed the system eventually able to produce risk versus return visualizations for all of these companies. And a time series based data for Apple stocks. I have taken one company where 20 days and 50 days moving averages have been generated from the data ingested through MongoDB, and then rolling wave 20-day visualizations. And then a very important as parameter in stocks visualization is RSI, which is 14 days RSI. So I was also successful in generating this curve. And then there are return curves. So so in financial terms, the most important curve is basically your monthly returns. And eventually I provided a conclusion and output summary. So shortly, this has been my project, and this project eventually demonstrates how big data storage systems and distributed processing frameworks can be combined to build a scalable and reproducible analytical pipeline. The emphasis throughout the project is on system design, persistent storage, distributed computation, and reproducibility, rather than just financial modeling. Thank you for watching.